Hello everyone, today we will introduce the overall workflow for constructing component-level realistic 3D models from point clouds, primarily using the Road Scene module in LiDAR 360 MLS software. First, let's briefly outline the overall steps for road modeling. After pre-processing the point cloud data, the first step is to extract traffic signs, road markings, and roadside facilities. Once the feature extraction is completed, the second step involves performing monolithic model enhancement in advance and setting the modeling rules. This includes defining the texture for road facilities, selecting model symbols, and configuring the relevant fields in the attribute table. After completing these preparations, you can proceed to the auto-modeling operation. First, you need to create a road area, which serves as the foundation for automatic road modeling. You can directly select an area on the point cloud as the road area or generate it using the roadside line as the boundary. Next, perform a topology check on the completed road area and its internal vector objects. Once the checks are passed, you can execute the one-click modeling operation. This includes modeling the road surface features and roadside facilities. For the constructed model, if you need to adjust its orientation, size, or model symbols, you can use the Model Editor functionality. Finally, you can choose to export the edited model. The software provides two export options: export road scene and export as an OBJ file. This concludes the overall steps for road modeling. Next, we will provide a detailed introduction to the entire operation process. Open the LiDAR 360 MLS software and create a new mapping project to save and reuse later. Load the point cloud, trajectory, and camera image files. If you don't have trajectory and camera image files, you can open just the point cloud data. In the Panorama Image module, you can view the panoramic images by selecting a frame. Check the Link 3D option to display both the point cloud and image data of the same scene simultaneously. In the subsequent texture selection step, you can refer to the panoramic image to choose suitable textures. Now, uncheck the Link 3D option and close the Panorama Image module. The view displays pre-processed point cloud data that has undergone deep learning classification based on the data collection scene. Next, you will need to extract features for traffic signs, road markings, and roadside facilities. Display the point cloud based on intensity. For traffic signs and road markings, you can use the functions in the Map Elements module to extract features such as lane lines, guide arrows, and crosswalks. Here is a demonstration of some functional operations. For a detailed usage tutorial, please refer to other corresponding demonstration videos. For roadside facilities like street lights and traffic signals, use the Facility module's functionality for extraction, such as the Pole Seed Editor for editing pole seed points. To remove incorrectly extracted or unnecessary pole seed points, you can select the points and press the Delete key. However, since pole-type facilities include various categories such as traffic signals, traffic signs, and street lights, after extracting the pole seed points, you will need to categorize them and place them into different point layers. For example, for street light points, Create a new layer for street light points and copy all points classified as street lights from the pole layer into the street light point layer. For the street trees along both sides of the road, you can use the seed editor function under the Urban Forestry module to extract seed points. Since this operation has been thoroughly covered in other videos, we will not go into further detail here. Once all the feature extraction is complete, you can proceed with monolithic model enhancement and set the modeling rules. Switch the Tool tab to the Road Scene page, and click the Model Symbol button. You can expand the monolithic model by adding symbols, importing models, and adjusting parameters for scaling, rotating, and translating. For detailed instructions, please refer to the video titled Model Symbols. Of course, you can also choose to use the model symbols provided by the platform by default. Setting modeling rules helps improve modeling efficiency and reduces post-modeling editing operations. The main content involves configuring the fields in the attribute table of modeling elements. For example, with directional arrows, road markings, you can see the fields M code and S code in the attribute table. Using these two fields, you can set the fill color of the directional arrows after modeling. By reviewing the panoramic imagery, it is evident that the texture of the directional arrows is pure white. At this point, you can open the texture manager and find the M code and S code corresponding to white in the solid color textures, which are 200002 and 1, respectively. Then, in the attribute table, use the field calculator or the copy-paste function to input the corresponding codes into the respective fields, thus completing the setup of modeling rules for the directional arrows. Similarly, for lane lines and other road surface elements, you can also customize the modeling width in the lane line layers attribute table. For pole-like facilities or street trees on both sides of the road, you need to manually add and set the M code field in the attribute table. First, open the texture manager and add the model symbols you intend to use under the symbol code map. You can choose the appropriate model symbol based on actual conditions. For example, for trees, select the model symbol code 100020 for the tree model, the code 100015 for the streetlight model, the code 100007 for the pedestrian signal, and the code 100014 for the traffic signal. After making your selections, close the texture manager. Open the attribute table for the street light point layer. For the road facility layer that does not have an M code field, you can create a new M code field. For the facility layers that already contain an M code field, add attribute values to the M code field in the street light attribute table based on the configured model symbol code. Taking the traffic light point as an example, open the attribute table and fill in the M code field with the corresponding symbol codes for traffic signal and pedestrian signal. The same procedure applies to other facilities. Once all modeling elements have their modeling rules set, you are ready to create the road area. This serves as the foundation for road automatic modeling. Activate the Create Road Area tool. You can either manually draw the road area or generate it using the roadside line as a boundary. For a detailed tutorial, please refer to the Create Road Area video. After the road area is completed, click on the Road Auto Modeling function to begin geometric quality checks on the drawn road elements. If any topology errors are found, make the necessary corrections according to the prompts, and then conduct the topology check again until no topology issues remain. Click the Modeling button to proceed with modeling the road surface elements. Next, use the Road Auto Facility function to model roadside facilities and street trees. For elements that have been modeled, such as road surfaces and flower beds, if you wish to change the texture, you can open the Texture Manager. In the Terrain Texture section, select a different texture pattern and click the Refresh button to apply the changes. For roadside elements, such as street trees, if modeling rules were not set in advance, resulting in the absence of corresponding tree models at the seed point locations after modeling, you can use the Add Road Facility Layer function to add the appropriate model symbols for the corresponding facilities. Additionally, the software provides the Add Building Layer function. By activating this feature, you can select a vector layer that contains building elements, choose the field that represents the building height, and click OK to complete the building modeling. The software will automatically select suitable textures for the buildings. Once the model construction is complete, if you need to adjust the model's orientation, size, or position, you can use the functions available in the model editor to make those adjustments. For instance, if you want to adjust the size of the streetlights, you can add a field representing the scaling value in the vector layer of the streetlights. Then, use the Scale by Feature Attribute or Absolute Scale by Feature Attribute tools to scale the streetlights. Additionally, the direction of the streetlight arm should normally be perpendicular to the road. If the direction is incorrect after modeling, you can use the Symmetric Rotation function. Select the modeling layer where the streetlight is located and rotate the streetlight to the correct orientation. For a few facilities with incorrect positions or orientations, such as traffic signals, you can use the Move Facility function to rotate or translate them. You can also add a rotation field in the Feature Attribute table to perform a rotation operation based on the feature attributes. In summary, the Model Editor tools provide comprehensive solutions for model adjustments, allowing you to achieve higher quality modeling results. You can select the appropriate tools based on your specific needs, and for features you are unfamiliar with, you can refer to the detailed tutorial videos available for these model editing tools. Finally, export the edited models. You can choose to export the entire road scene or use the Export Road Models function to export the constructed models in OBJ format. Additionally, with the Import Road Scene tool, you can re-import the exported road models. All the tools mentioned have detailed tutorial videos available for your reference as needed. This concludes the complete introduction to the road modeling process. Thank you for watching.